Introduction. Gravimetric analysis is a classical analytical chemistry technique based on the measurement of mass. In this method, the analyte is converted into an insoluble solid, which is then filtered, dried, and weighed. It is known for its high precision and does not require calibration, like modern instruments. In this presentation, we will demonstrate how this technique is used in real-life application, particularly in the detection of sulfate ion in drinking water. Objective: First, to demonstrate how gravimetric analysis is used to determine sulfate ion (SO4 negative) in drinking water. Number two, to explain the theory, procedure, and calculation involved in the process. And the last one, to show the relevance of this method in real-life water quality testing.
Okay, now we move to the theory. So in this experiment, sulfate ions react with the barium chloride to form barium sulfate, a white insoluble precipitate. The reaction is as follows: SO4 2 negative, which is aqueous, plus Ba2 plus aqueous, and BaSO4 solid will be produced. The precipitate is filtered, dry, and weighed. The amount of sulfate present is calculated using the gravimetric factor, which is the ratio of the formula weight of SO4 2 minus 2 that BaSO4.
I will be explaining the application of gravimetric analysis in daily life. So, first of all, why analyze sulfate in water? Sulfate ions occur naturally in water and in high concentrations. This can affect the taste of water and cause health issues such as diarrhea. Therefore, monitoring sulfate levels is important for public health. Gravimetric analysis is commonly used in water treatment plants, environmental monitoring, and educational laboratories because it is simple, cost effective, and very accurate.
Now, I will explain the experimental procedure that we follow. First, we began by collecting a water sample. To this sample, we added barium chloride solution while continuously stirring. This caused barium sulfate to precipitate out. Next, we gently heated the mixture. This step helped the particles to coagulate, making them easier to filter. Then, we used filter paper to separate the solid precipitate. To prevent peptization, we wash the precipitate with a diluted electrolyte. After that, the precipitate was dried in an oven at around 110 Celsius. Finally, once dried, the barium sulfate, or BaSO4, was weighed using an analytical balance to complete the process. This entire procedure ensures accurate measurement of sulfate in the water sample. Let's now look at the sample result and how the calculation is done. In this example, we obtain 0.200 grams of dry barium sulfate or BaSO4 from a 100 milliliter water sample. To calculate the amount of sulfate ion, SO4 2 negative, we use the gravimetric factor, which in this case is 0.3430. So, the mass of sulfate can be calculated using this formula, which is mass of SO4 2 negative equals to 0.200 grams times 0.3430 equals to 0.0686 grams. This means the water sample contains 68.6 milligrams of sulfate. This calculation helps us determine how much sulfate is present in the water, which is important for water quality analysis.
So, in conclusion, Gravimetric analysis is a simple and reliable method for determining the amount of specific ions in a solution. The example of sulfate determination in water demonstrates how this classical technique remains relevant in modern analytical practices. It is widely used in industries due to its accuracy and cost effectiveness, especially where high precision is required.